Okay, so today we're going to take a look at how we could measure parts of another kind of solid we're going to call a pyramid. Last time we took a look at prisms. We said a prism was a polyhedron or a closed three-dimensional solid made up of polygons where two of those faces, two of those polygons were parallel and congruent. Pyramid's a little bit different. You can kind of tell by this one I have drawn for you here. I've got faces. I've got some faces that look like they're triangles. And then I have this one face that looks like it's a square. So this is really typical for a pyramid. You always have a bunch of faces that all meet at one point, and they're all going to be triangles. We call those the lateral faces. So this triangle here, and this triangle, and this one, blah, blah, blah. Those are all what we call lateral faces. They're all going to meet at one point up here. That's called the vertex of our pyramid. That one face that doesn't meet at that one point. So for example, this square down here, this is going to be what we call the base of our pyramid. And just like with prisms, the base depends on, or I should say, the base determines what kind of pyramid that you're going to be working with. So this one we would classify as like a square pyramid. You can have triangular pyramids, so a base that's a triangle. You could have a pentagonal pyramid, so regular pentagon, so on and so on and so on. That base is going to tell you how to do different area formulas. We're going to find the area of those bases, so we have to remember from chapter 11, like 1/2 perimeter times apothem, or whatever formula we might need for any given base. So I want to point out another thing with pyramids. With pyramids, you also have two different heights. So if you take a look at the black segment here from E down to G, I know it's hard to see that G. This vertical looking one, that's going to be what we call the altitude of our pyramid. That's just the straight up and down height. So if someone said this pyramid is 20 feet tall, that's what they're talking about. The other height I want to look at is this red one. So that red segment that's going from E to F, that is going to be what we call the slant height. That's a height that's going down the slant of our pyramid. So that red slant height is going to be the height of every triangular face. So if you look at this triangle on its own and say you wanted to find the area of this triangle, well, you do 1/2 of this base length times the height of my triangle would be that red segment. That's how tall my triangle is in that slanted plane. So we're actually going to be using slant height for areas. We're not really going to focus on the altitude. That's going to be something we'll need for volume. But I should warn you, sometimes they're going to give you the altitude. You might need to set up a right triangle and solve for different parts. So you have had a lot of practice with that. So we should be good at that by now. So what I'm going to do is imagine from the top here, let's say that we kind of like undid all of these connections and we folded this thing flat. We should get a picture that looks something kind of like this. There's my base, and then I have those 4 triangles that are making up the lateral faces. I kept that red segment for my slant height. So let's say that I wanted to find the lateral area. That would be the area of all 4 triangles there, and they're all going to have equal area. Well, for triangles, I need the base length and I need the height. Well, this has a height, I'll call it L for slant height. Your book does the same thing. If I want to find the area of that one triangle, that would be 1/2 B times L. Excuse me, 1/2 B times L. Now I chose B. It could have been really any variable. Also, since this is a square, all of those should be B. And therefore all of these will have the same area because they'll all have the same height as well, the slant height. If I look at all 4, I'd have 4 times 1/2 base times slant height. Now this tells me right here the lateral area of my pyramid because this is the area of all my lateral triangular faces. I'm going to focus on that 4 and that B and just move some things around. So if I take a look at those 2 parts of this calculation or this formula, you're allowed to move things that are multiplying. So I'm going to swap the 4 and the 1/2, see what happens. So I get 1/2 of 4b times L. Okay, why would I do that? Well, if I look at my base is a square. And if I look at 4b, that's the same as the perimeter of my base. And the same thing would happen if I had a triangle or a regular hexagon or really any other base. This is always going to come out to be the same thing, where you get 1/2 of the perimeter of your base times the slant height of your pyramid. This right here is going to be our formula for lateral area of a pyramid. And this works for all of the pyramids that we're going to work with. If we wanted to find the total area, well, what we would need to do is add in the area of our one singular base. And so that would look like 1/2 perimeter of the base times the slant height of the pyramid plus the area of that base. I'm going to use capital P for perimeter of base and capital B for area of the base. We're going to do that for the whole chapter. So that right there is our total surface area of the pyramid. One way you can kind of remember this is we should remember the formula for prisms. So for prisms, our total surface area was perimeter of base times height of prism plus 2 times area of the base. Well, for pyramids, we don't look at the height, we look at the slant height, and we don't have 2 bases, we only have 1. So if you were to take that and divide by 2 and replace H with L, well, that's going to give you the total surface area of a pyramid because you only have 1 base and you're not looking at the altitude, height, and the way we normally think of it, you're looking at the slant height. So those are the 2 formulas we're going to need. Lateral is 1/2 perimeter times slant height. Total is 1/2 perimeter times slant height plus area of the base. So in the next few videos, we're going to practice using these formulas.